Alright, this is Euclid Book 6, proposition number 29. And if you want to get screenshots, I'm going to go ahead and give you these. This is going to be the main one right here. You're going to have this one right here. You're going to have this one right here. And you're going to have this one right there. Like I said, I would encourage you to get screenshots of this because this is super huge. Alright, now here comes the actual proof. I'm telling you, this has been a bear. It took me over an hour to find this one myself. So these numbers will actually work. It's the only ones that I figured out that actually work. Let's read it together, shall we? To a given straight line, to apply a parallelogram equal to a given rectilineal figure and exceeding by a parallelogramic figure similar to a given one. Wow, that's a mouthful. Let AB be a given straight line. Well, here is A right here. Here's B right here. You can follow along with the screenshots here. C is to be a given rectilineal figure. Here's C right here. Okay. Let AB be the given straight line, which I just showed you. C the given rectilineal figure to which the figure to be applied to AB is required to be equal. So we're going to apply a figure onto this line right here that's going to be equal in area to this one right here. And D to which the excess is required to be similar. Okay, so somewhere along here we're going to apply a figure that's going to be similar to this one. Not equal, similar. There's the trick. That is required to apply to the straight line AB a parallelogram equal to the rectilineal figure. Okay, yeah, we got that. Let AB be bisected at E. Does that sound familiar for the last proof that we did? Let there be described on EB, well, here's EB right here, the parallelogram BF. What's the parallelogram BF? Well, it's B, E, F, and L. This one right here. And this parallelogram has to be similar and similarly situated to D, in which it is. And how do you know that? Well, because this line is 1.5 inches long and this line is 1 inch long. And as this is to this, so is 0.75 to 5. Okay, see, there's 0.75, there's 5 right there. Alright. And let GH be constructed. Well, here is GH right here. You got G, H, and K right here. And it is equal to the sum of the area of BF, which we said was right up here, and C, this one right here. Okay. The area here plus the area here is the same as the area here, and this has to be similar and similarly situated to D. So GKH is similar and similarly situated to D. This is by Euclid Book 6, proposition number 25. You want to go back there and take a look at that. Let KH correspond to FL. Okay, here's FL, and here is KH. And as you can see, 3 corresponds to 1.5. And KG to FE. Well, here is FE here, right there. And here is KG, and here is 2 is to 1. All right. Now since GH is greater than FB, well, since this is bigger than this parallelogram is bigger than this one, therefore KH is also greater than FL. KH is bigger than FL. And KG obviously is bigger than FE. Let FL and FE be produced. So we're going to extend FL here, and we're going to extend FE down here. And now we've got FLM. And of course FLM is 3 inches long. And FEN is of course 2 inches long. So FLM is the same size as KH, and FEN is the same size as KG. And let MN be completed. Well, now you have FMON, this giant square right here. Now you have it. Therefore MN is both equal and similar to GH. MN is equal in area to GH, and MN is also similar to GH, okay, because as 2 is to 1, so as 3 is to 1.5. Okay? But GH is similar to EL. GH here is similar to EBLF. Similar to this one too. And this is by Euclid Book 6, proposition number 21. Therefore EL is about the same diameter with MN. EL is about the same diameter with MN. Well, EL is EBLF, and MN is MFNO. Okay. And this is by Euclid Book 6, proposition number 26. Let their diameter FO be drawn. FO is now going to be drawn. It's actually FB and O. Okay. And let the figure be described. Okay. So what we're going to do is we're going to extend EB onto P, and we're going to extend LB down to Q. Since GH is equal to EL and C, well, GH, that area there is the same amount as if you added the area of EL, which is this one here, which is FL, EB right there, that area there, plus C right there. While GH is equal to MN, the area of this is the same area as this. Therefore, the area MN is also equal to EL and C. So if you were to take the measurement of the area of this here, and you added this plus this, you'd find they'd be the same amount. Let EL be subtracted from each. Okay. We're going to subtract the area of EBLF from MFNO, and we're also going to subtract it from GH. Okay? Now we have a nomen. Okay? And I'm going to mark this nomen for you in this video. Okay, let me say that again. We have a nomen, and we're going to mark it right here, right now. It's called XWV. Well, that nomen is this. Actually, that's not right. Should be this side. Okay. And it's going to be this gnomon right here, XVW, right across here. And it really doesn't matter how you label it, really, as long as you get the main point across. Therefore, the remainder, the gnomon XWV, which we just said right here, is equal to C. So if you were to add the areas of this, plus this, plus this, you get the same area as this. Now, since AE is equal to EB, AE and EB, these two lines are the same length. AN is also equal to NB. So the area of AN, well, this is AEN and whatever letter you want to call this. And that area there is the same size as NB. Well, NQBE, that's this area right here. So this area is the same amount as this area. And this is by Euclid Book 1, proposition number 36. That is to LP. Where is LP? Well, LP is L, and we're going to go ahead and call this X. LXPM, you don't really have to call it X, so actually we call it B. I'm sorry, we'll call it B. LBPM, this area right here. Okay? Area in here is equal to the area in here, and the area in here is also equal to the area in here, because the area in here is also equal. So let's go one more time, step by step. The area in this rectangle right here is the same as the area in this rectangle right here, and the area in this rectangle right here is the same as the area in this rectangle right here, because the area in this rectangle right here is the same as this. And this is by Euclid Book 1, proposition number 43, if you don't believe me. Let EO be added to each. Well, what is EO? Okay, the area of EO is actually E, N, O, and P. Okay? Now then, so we're going to add this giant area right here to this. We're going to add this giant area here to that. Therefore, the whole AO, A, P, O, and whatever this letter is right over here, whatever you want to make it, this whole area right here is going to be the same size as the gnomon XWV. All these three boxes. So if you were to add the areas of all three of these boxes together, and you were to add the area of all three of these boxes together, they'd be the same size. Okay. But we also proved that this gnomon, which is VWX, this box plus this box, we had said that if you add these three boxes together, the areas of all three of them together, they would equal C. Therefore, if you were to add these three boxes together, they'll also equal C. So the area in these three boxes put together is this. Therefore, to the given straight line AB, there has been applied a parallelogram AO. A, P, O, and whatever letter you want to call that. That whole area right there. Equal to the given rectilineal figure C. Boom. Area here, same as here. And exceeding by a parallelogramic figure QP. Well, QBPO, this area right here, is what they call exceeding, which is similar to D. This is actually similar to D. since PQ is also similar to EL. Well, PQ is similar to EL. Okay. So the sides about PQ are in a ratio to this one right here, which actually ends up being a 1-to-1 ratio in this particular case, which is by Euclid Book 6, proposition number 24. And that's the end of that proof. We did it, people. We got through it all right. We got 4 more proofs, and then we're going to start talking about prime numbers. And I'll tell you what, you don't want to miss that discussion. I will tell you more in a future video. Stay tuned.